Welcome to MH class. Today we'll discuss some points on introduction to Euclid's geometry. Okay. Till now we discuss fifth axioms and seven axioms and five postulates on Euclid's geometry, and also we discuss about the questions of exercise 5.1. So let's see what are the extra things. Some points to be remembered. What are some points to be remembered? First point is two distinct lines cannot have more than one point in common. So two distinct lines cannot have more than one common point. So to need to common point, we have to intersect the lines. So if we draw any two distinct lines and if we intersect them, what is the common point? Only one common point. In which way? In which way you draw? Only one common point will get. Okay, so two distinct lines cannot have more than one common point. So be careful here. Second point is two lines which are both parallel to the same lines. Suppose this is a line, L is a line. L is parallel to M. L is parallel to M. Again, M is parallel to N. M is parallel to N. Then what we can say? L is parallel to N. That means what? If L is parallel to M, M is parallel to N, it implies L is parallel to N. Okay? Next, if L, M, N are three lines in the same plane such that L intersect M and N is parallel to M, L intersect M, okay, and N is parallel to M. This is L, this is M. L intersect M, and one more line is that N is parallel to M. That is, N is parallel to M. Then what will get? L will also intersect N. Okay, this is the third point to remember. Next is if L and M intersecting lines, L M are intersecting lines, and L is parallel to P. This is L, and this is M. L and M are intersecting lines. Okay, L is parallel to P. This L is parallel to P. This L is parallel to P. And L is parallel to Q. L is parallel to Q. This N is parallel to Q. First one is L is parallel to P, and N is parallel to Q. Then P and Q intersects. Then P intersects Q. P and Q are intersecting lines. Okay, this is the fourth point you have to remember. These are not discussed in the Euclid's geometry. These extra points you have to remember. Okay. Next, see equivalent version of the Euclid's geometry. What is the equivalent version of the Euclid's geometry? For every line L, for every line M, L, and for every point P, L is a line. This L is a line. Okay? L is a line. And P is a point not lying on L. This is a P. Point not lying on L. This is L. This point is L. Line is L. L is a line, and P is a point not lying on L. There exists a unique line in passing through P and parallel to L. Whatever we draw the lines, we can draw the lines in this way, this way, this way. Infinite number of lines we can draw. But only one line is that which is passing through P and parallel to L. we will get only one line, unique. That line is unique. Okay, and two intersecting. Second point is equivalent. That is two distinct intersecting lines. Two distinct intersecting lines cannot be parallel to the same line. Two distinct intersecting lines. These are two distinct intersecting lines. These are two distinct intersecting lines. So L is intersecting to M. And if we say L is parallel to P, L is parallel to P, L is L is parallel to P. Okay, L and M are intersecting lines. L is parallel to P. Then M is, in this case, we cannot say M is this P. M cannot be parallel to P. Okay, two distinct intersecting lines. Both of them cannot be parallel to the same line. Any one of them can parallel to any one line, but both of them cannot be parallel to the same line. Similarly, if we draw a parallel line through M, suppose if we draw a parallel line to M, that is N. So N is not parallel to L. M is parallel to N. In this case, L is not parallel to N. So from here, what we can say? If two distinct intersecting lines, if we draw, out of them only one is parallel to one line, and that parallel line is not the parallel to other lines. Okay, these are the points you have to keep in your mind. Next, see the question. Now see the exercise questions. What is the exercise question? First is what would you rewrite Euclid's fifth postulates so that it would be easier to understand? It would be easier to understand. Okay, the fifth postulates is what? This was the fifth postulates. If these two angles are not some of the interior angles of this, a line is intersecting two lines, and some of the interior angles of one side of this line is not two right angles, then the lines never be parallel. They will intersect at somewhere. They will intersect at somewhere. These two lines will be intersected somewhere. So that we can write in this way. This point we can write. See, two distinct intersecting lines. Lines cannot be parallel to the same line. Okay, this is the, we can write the Euclid's fifth postulates in this way also. Two distinct intersecting lines cannot be parallel to the same line. Question number 2. What is question number 2? See question number 2. What is given? Does Euclid's fifth postulates imply the existence of parallel lines? So Euclid's fifth postulate is, what is the Euclid's fifth postulates? Euclid's fifth postulates, already got that. If a line intersects two lines, if a line falls in two lines, and the interior angle, some of the interior angles of the same sides of the intersecting lines is not two right angles, then both the lines will be meet at any way. They will intersect each other. Okay, but here, does the Euclid's fifth postulates imply the existence of parallel lines? Yes. Why not? If the sum of the angles is two right angle, sum of the angles two right angles. Okay, if sum of the angles is two right angle, that means if we draw in this way, this is L, this is L, this is A, this is B. Now if sum of these two angles is true right angle, these two angles is true right angle, then what will get? The lines are parallel. These two lines are parallel. They will never intersect. Interior angles on the same sides, two right angles. Then the Eclipse Fit postulates the lines A and B will not meet on the side L. They will not meet here. As this arm is two right angle, similarly we will get here also two right angles. So if this side is not meet anywhere, this side also not meet anywhere. That means what? Never they will meet anywhere. The line A and B never will meet to each other. That means the line A and B are parallel. That's we have written here. If a straight line L falls on two straight lines, falls two straight lines A and B, such that sum of the interior angles on the one side, this sum is one side, sum is 180 degree or two right angles, then by the Eclipse Fit postulates, how we can say the lines A and B will not, these two lines will not meet on the side, on this side of L. They will not meet this side. Okay. Next, we have also the sum. This side also we have to sum. Next, we have also the sum of the interior angles of other sides of the lines L be two right angles. Here also we will get two right angles. Okay. Here also we will get two right angles. So that this side also they will not meet. Therefore, they will not meet on the other sides also. So the lines A and B never meet and therefore parallel. Therefore, they are parallel. Okay? They will never meet, therefore they are parallel. Clear? Any problem? So this is the end of this exercise questions, exercise 5.2. I think you understand. If any doubt, let me know, inbox the message. Okay, thank you, have a nice day.